User experience in virtual reality. Fundamentals. Immersion. Creates a sense of being inside the virtual world. Visual immersion. High-resolution visuals and wide fields of view simulate realistic environments. Auditory immersion. 3D spatial audio enhances realism by accurately positioning sounds. Haptic feedback. Vibrations or pressure simulate touch and interactions in VR. Presence. The feeling of being there in the virtual world. Sense of embodiment. Users feel like their virtual body is part of the environment. Spatial awareness. Awareness of surroundings and objects within VR. Emotional engagement. Stimulates feelings or reactions by mimicking real-world scenarios. Design principles. Intuitive interactions. Simplifies user interaction with the VR environment. Natural mapping. Aligns virtual controls with real-world actions, e.g., grabbing with a hand controller. Affordances. Objects in VR should suggest their use naturally, e.g., a button looks placeable. Ergonomics. Designs prioritize user comfort, reducing strain during prolonged use. Minimizing discomfort. Motion sickness mitigation. Techniques like teleportation or high refresh rates prevent nausea. Eye strain reduction. Proper resolution, lighting, and focus adjustments reduce visual fatigue. Comfort optimization. Lightweight and well-balanced equipment prevents discomfort. Input modalities. Hand gestures. Interaction through natural hand movements. Finger tracking. Detects individual finger motions for precision in VR. Eye tracking. Captures eye movements to enhance accuracy. Foveated rendering. Improves performance by rendering high detail only where the user is looking. Voice commands. Enables hands-free interaction using spoken words. Speech recognition. Processes verbal commands into actions. Multimodal interaction. Combines speech, gestures, and gaze for intuitive control. Visualization techniques. 3D user interfaces. Interfaces that exist in 3 dimensions, allowing natural interaction. Spatial data representation. Presents data in a 3D spatial context for better understanding. Volumetric displays. Projects fully 3D objects visible from all angles. Data physicalization. Represents abstract data in a physical form. Holographic projections. Creates hologram-like visuals for better immersion. Interaction paradigms. Teleportation. Allows users to move instantly to a new location in VR. Seamless navigation. Smooth and continuous movement through virtual spaces. Object manipulation. Direct grasping. Picking up and moving objects with virtual hands. Indirect control. Using controllers or tools to manipulate objects. Collaborative experiences. Shared VR spaces enable multiple users to interact in real time. Multi-user coordination. Collaboration on tasks within VR. Shared virtual spaces allows users to coexist and interact in the same virtual world. Evaluating VR experiences. Usability testing. Identifies how easily users interact with VR systems. Task performance metrics. Measures efficiency and accuracy of users completing VR tasks. User feedback surveys. Collects subjective opinions on VR experiences. Physiological measurements. Tracks physical responses to VR, e.g., heart rate, sweat, eye movements. Eye tracking data. Monitors focus and engagement. Biometric sensors. Measure physical states like stress or relaxation. Qualitative assessments. Observation studies. Records how users behave in VR. Ethnographic interviews. In-depth interviews to understand user experiences. Emerging trends. Haptic interfaces. Advanced tactile systems to enhance realism. Tactile displays. Simulate texture and surface contact. Force feedback devices. Provide resistance to mimic physical interactions. Augmented reality, AR, integration. Combines AR with VR for blended reality experiences, overlaying virtual content on real-world environments. Contextual information overlays. Displays relevant real-time information in the user's field of view. Brain-computer interfaces, BCIs, Cutting-edge technology enabling neural interactions with VR. Neural interaction. Brain signals control virtual actions. Thought-controlled interactions. Mind-driven commands replace physical inputs.